Myself Prayak Patel, working as assistant professor in IT ICT department of LJ Institute of Engineering and Technology. Now in today's video lecture, I will discuss about the sorting algorithms. We already discussed the sum sorting algorithms. Now in today's video lecture, I will discuss about the cell sort and Radix sort sorting algorithm. Now understand one by one algorithm. First consider the cell sort method or cell sort algorithm. Now consider the one example. For understanding the cell sort example or algorithm, sort the following element in ascending order using the cell sort technique. Consider the element as a 80, 93, 60, 12, 42, 30, 68, 85 and 10. Now consider the step number 1. Divide the input array into the segments where initial segment gap consider equal to 4. How we can consider the initial segment gap? Here consider the first step as a divide the given data into the different segment. So here consider the segment and segment size. So segment size consider as a segment gap. Segment gap equal to n divided by 2. So here consider the total number of element as a n, and n divided by 2 consider as a initial segmenting gap. So here consider the n by 2 and semantic gap consider as a 4. So initial segmenting gap equal to 4 means you compare the next fourth element, means you compare the first element, then fifth element, then 10th element, like this, means consider the semantic gap equal to 4. So initial consider this given data as a 80, 93, 60, 12, 42, 30, 68, 85 and 10, and position consider as a location 1 to 9. So initially, according to step number 1, semantic gap equal to 4. So here consider the initial position 1, location 1 compare with the location 5. Why we consider the next location as a location 5? Because initial location as a 1 plus your semantic gap. So 1 plus 4 equal to 5, then 5 plus 4 equal to 9. So consider the next fourth element. So gap of the your particular given data is considered as a 4. So compare the location 1, 5 and 9. You can consider only these three locations and sort only these three locations, location 1, location 5 and location 9. So in location 1 consider the value as a 80, location 5 consider the value as a 42 and location 9 consider the value as a 10. So out of these three, which one is smallest value? 10 consider as the smallest value. So first put the 10 at location number 1. Then next value consider as a 42. So 42 put at location 5. And third value is 80. So 80 put at the location 9. So only you can perform the operation on these three locations. First 1, 5 and 9. And after the sorting, you can consider the second array as resultant array. After the step number 1, 5 and 9 location consider as a sorted location or sorted data. 10, then 42, then 8. So after that only three locations are considered as a sorted. Same process will be executed for each and every location. So next step is consider the location number 2. Now which location will be compared with location number 2? 2 plus 4 consider as a 6. So 2 compare with the 6. Now next consider 6 plus 4 equal to 10, but 10th location is not available, so you can only compare the location 2 and 6. Now consider the value for location 2 and 6. Value of location 2 equal to 93 and 6 equal to 30. Now sort these two elements. So minimum value equal to 30, then 93. So first we put the 30 at your location number 2 and 93 at location number 6. After that consider the next location, location number 3. Now third location compare with the 7th location because 3 plus 4 equal to 7. Now here consider the value as a 60 and 68. Already sorted, no any swapping operation will be done. So 60 and 68 as it is for location 3 and 7 respectively. Now next consider the location number 4 compare with the location number 8. So here you can compare the data according to your position wise. Your fixed semantic gap is given and according to that you can compare the element. So here comparison between 4 and 8. So at location 4 consider the value as a 12 and location 8 value as a 85. Here consider the 12 as a minimum value, 85 as greater value. So consider the fourth location value consider as a 12 and at 8 location value as a 85. So this is a resultant array after the step number 1. In step number 1 we consider semantic gap equal to 4. Now consider the next step, step number 2. In step number 2, consider the semantic gap equal to n by 2. Means initially we consider the n by 2. Now consider n equal to your previous semantic gap. In step number 1, your semantic gap equal to 4. So here in step number 2, consider the n equal to 4. So 4 divided by 2 equal to 2. So next for the step number 2, consider the semantic gap equal to 2. Means you compare the next second element. So initially consider the process like 1 compare with 3, 5, 7 and 9. Because here consider the semantic gap equal to 2. Means 1 plus 2 3 plus 2 5 plus 2 7 plus 2 9. Means next second location will be compared. So here compare the element 1, 3, 5, 7 and 9 location. Means value consider as a 10, 60, 42, 68 and 80. Out of this all value consider the minimum value as a 10. So put the 10 at location number 1. Then next value consider as a 42 minimum value. So 42 put at location number 3. The next consider the value 60. So 60 put at location 5. Next value 68 put at location 7. And last value 80 put in location number 9. So after the first step compare 1, 3, 5, 7 and 9. You will get the resultant array as a this. Now consider the next location 2, 4, 6 and 8. So for this location consider the value as a 30, 12, 93 and 85. Now after that consider or arrange the given for location 2, 4, 6 and 8 into the ascending order. So here consider the minimum value as a 12. So put the 12 at location 2. Then next value consider as a 30. Then 30 put at location 4. Then 85 put at location 6 and 93 put at location number 8. So here consider this is a final step of the step number 2 or final array of the step number 2. After that consider the step number 3. In step number 3 consider the semantic gap as a 1. Because in our previous step consider the semantic gap equal to 2. So in this step 2 divided by 2 equal to 1. So last semantic gap consider as a 1. Now consider the array of your previous step resultant array 10, 12, 42, 30, 60, 85, 68, 93 and 80. Now semantic gap equal to 1 means compare each and every location. Means 1 compare with 2, 3, 4, 5, 6, 7, 8 and 9. All the location will be compared at a time. So here consider the in previous step we will get the result like your data is near to sorted. So in last step you sort the nearly sorted data as a sorted list. So compare each and every location and arrange your data into the ascending order according to cell sort. So resultant array consider as a 10, then 12, 30, 42, 60, 68, 80 and 80, 85 and 93. So this is considered as a final sorted array using the cell sort algorithm. So this is a simple cell sort technique. Now consider the cell sort technique process. First step is divide the array into several smaller non-continuous segments. So you can consider the segment gap as a 4, 3, 2, 1 like this. Next step is the distance between successive element in one segment is called the gap, means semantic gap. Third step is each segment is sorted within itself using the insertion sort algorithm. Means you can compare 1, 4, 9 location and arrange these 3 locations using the insertion sort technique. Step number 4, then resegment into the larger segments, means smaller gaps, and repeat the sorting process. Continue until only one segment is left, means you can perform the operation up to the segment gap equal to 1. Means initially you consider the segment gap equal to 4, then 4 by 2 means 2, then 2 by 2 means 1. Means your last step is considered as a semantic gap equal to 1. So this is a process for cell sort algorithm. And final sorting finish the entire array as a sorted array. So this is a simple cell sort algorithm. Now consider the another algorithm of sorting is Radix sort algorithm. So consider the Radix sort algorithm. Now first consider how Radix sort algorithm will work. Radix sort put the element in order by comparing the digits of the number. Means here consider the Radix sort algorithm. In Radix sort algorithm we consider the one variable as a d, means number of digit consider as a d. So you can perform the operation as a digit by digit, means consider as a last digit, then second last digit, then first digit, like this. Each element in the n element array A has d digits, where digit 1 is the lower order digit and digit d is the highest order digit. Means you can consider 3 digit number like 363. So in this case last element or last value consider as a lower bit and first bit consider as a higher bit, and higher bit consider as a digit number d. So here consider the algorithm for Radix sort. Radix sort A D. A as a given array, D means number of digit in here given data. Now for I equal to 1 to D means 1, 2, 3, 4 up to D digit. So first I equal to 1 means you can perform the operation for the digit number 1 only. Then I equal to 2 means you can perform the operation for digit number 2. Then I equal to 3 means you can perform the operation for digit number 3. Then I equal to 4 means perform the operation for digit number 4, like this. Do use a stable sorting algorithm for sort the given data A, array A. So this is a simple algorithm for Radix sort. Now understand the Radix sort algorithm using one example. Sort the following elements in ascending order using the Radix sort technique. So first given data is 363, 729, 329, 873, 691, 521, 435 and 297. Now consider the given data in this order. Now you can sort the data digit by digit. So initially consider the sort the data according to column number 1 or digit number 1, means this column consider as a column number 1 or digit number 1. So you can arrange or sort the data according to digit number 1. Now for that consider the any digit here given data in form of decimal number. So your last digit or any digit consider as a value from 0 to 9 only. So you can consider one table from location or value as a 0 to 9. Now in this location, here we consider only the last digit of given data. For example 363, last digit consider as a 3. 297, last digit consider as a 7. And according to your last digit, you will put your data into this table. So initially consider first value as a 363. Then last digit is 3, then put this value into the column number 3. So 363 in column number 3. Then 729 put into the column number 9. Then 329 last digit is 9. So put this value into the column number 9. But in column number 9 already one value is 729. Now second value is 329. So put the 329 on the upper side of the 729. Then 873 last digit is 3. So put into the column number 3. Then 691 last digit is 1. So put into the column number 1. Then 521 put into the column number 1. For 35, so last digit is 5. So put into the column number 5. Then 297 last digit is 7. So put into the column number 7. After that consider the given data or this table, and according to this table you can arrange the data after your sorting of the column number 1. So consider this table as your step number 1. Then according to bottom up fashion you can consider the element one by one. If here the given data in each and every column only one data are given, then no need to worry about that. Only we can consider the location from left to right. Means first consider column 0, then column 1, column 2, column 3 up to column 9. But in any column you have a more than one value, then in this case consider the value from bottom to top. So here in first column consider the 0 column as an empty column. Then column number 1, two value are there, 521 and 691. But you can consider the value from bottom to top fashion. Means here first consider the 691, then 521. So after the first operation or according to column number 1 operation, sorted list after the sort on column number 1 consider as a 691, 521, then column number 3, 363, then 873, then 435, then 297, then 729 and 329. So after the first step you can find the data as a this type of location. Now according to your previous step result, means this list consider as a result of the step number 1. According to this list you can perform this step number 2. In step number 2 you can consider the data of the output of the step number 1 as an input for step number 2. In step number 2 you can consider the column number 2, means consider the second digit. So digit number 2 or column number 2. Same process will be repeated for the column number 2. So here consider the first value as a 691. Here consider one table from location 0 to 9. First is 691, put into the column number 9 because second digit is a 9. Now 521, put into the column 2. 363, put into the column 6. 873, put into the column 7. 435, put into the column 3. 297 in column number 9, 729 in column number 2, 329 in column number 2. Now after that consider this table 0 to 9 column as your resultant table of this step number 2. Now in any column you have a more than one value, then consider the bottom of value, means first consider the bottom value then top value. So according to this consider the sorted list after the sort on column number 2 consider as a 521, then 729, then 329, then 435, 363, 873, in last column 691 and 297. So this list is after step number 2 your resultant list. Now consider the third step. In third step consider the input as a result of the step number 2 and consider the step number 3 as a column number 3 or sort according to column number 3. So here consider the column number 3 and according to this you can sort the data. Now consider the table of the column 0 to 9 and put the value one by one. First 521 put into the column 5, then 729 put into the column 7, then 329 in 3, 435 in column 4, 363 column 3, 873 in column 8, 691 in column 6, 297 in column 2. Now after that consider the sorted list or final list of the sorted element. Here consider the from bottom of fashion you can first consider the 297, then 329, 363, then 435, 521, 691, 729 and 873. So this is a final sorted list according to Radix sort. So in Radix sort you first consider the last digit, means digit number 1, then digit number 2, then digit number 3 up to the D digit and perform the operation of the arrange the data or sort the data in ascending order. So here consider final sorted list as a this list after the column number 3 sorting. So same example can be performed like this. First here consider the minimum value according to column number 1. So here consider the sort on column number 1 process. You can perform the operation like this also. So here consider the sorted on column number 1. So in column number 1 consider the minimum value as a 1. So first minimum value is 691, then 521 put after the 691, means second value 521, then third value here consider the 363 according to column number 1 only, minimum value from the column number 1. So here fourth value is 873, next value 435, next value consider as a 297, then 729, then 329. So put the value each and every value according to column number 1 only. So this list consider as a sorting list after the column number 1 operation will be done. Now consider the second step. In second step consider the sort on column number 2. In this process consider the minimum value as a column number 2 value. So here minimum value as a 2. So first consider the 521, next consider as 729, then 322. After that consider the 435, then 363, then next value as a 7, so 873, then 691 and 297. So put according to column number 2. Now last step, sort the data according to column number 3. So here first digit consider as a column number 3. So digit number 3 or column number 3. Now consider the minimum value as a 2. So first 297, then 329, then 363, then 435, next value 521, then 691. So put next 5 after 521, consider 691, then 729, then 873. So this array consider as a final sorted array according to Radix sort algorithm. So you can sort the given data according to Radix sort algorithm in ascending order, as well as you can perform the operation for the descending order also. So in today's video lecture, I will discuss about the cell sort and Radix sort example. Thank you for watching this video.